Welcome everyone. Let's keep going on our intro to Rhino. So by now we've done 2D tools and commands. We've done surfaces over here. We've done open and closed polysurfaces. So let's carry on with closed polysurfaces, meshes, and object relationships. These exercises match the chronological order of 3D modeling in Rhino. You're generally going to start with 2D geometry, 2D shapes and lines, and build those into surfaces, polysurfaces, and then once you have various parts for things, you can assemble those into a greater form, a greater whole. So this is one of the best tools for doing that. Boolean union, Boolean difference, Boolean two objects, Boolean split, and Boolean intersection. Let's just run through these in order and see how they affect relationships of 3D objects. So I've got, if I look in the command history, one closed polysurface added to selection, and another one. I know this command history, I've been clicking on a lot of closed polysurfaces, but if I scroll down, I can see the most recent selection. So that's just to verify that these are the way that they need to be. All right, let's start with Boolean union. So I type Boolean union in the command bar, and I'm asked to select surfaces or polysurfaces to union. So I'm just going to click on one of these cubes and then the other, and then press enter. And now if I just click on one cube, they both highlight, and if I try to move them around, they both move together. So now this is one solid piece. I'm going to Control Z and undo that union. Okay, now they're both separate again. Boolean difference is our next one. So in the command bar, Boolean difference, select surfaces or polysurfaces to subtract from. So for this one, I'm going to start with one, and then press enter to continue. And now I'm asked select surfaces or polysurfaces to subtract with. So now I'll choose the other cube and press enter. And this is the effect that Boolean difference has on a pair of 3D objects. Let me Control Z and undo that. Now let me just do it the other way around. So Boolean difference. I'll start with the other cube this time, enter, click the other cube now, enter, and it subtracts a portion of the other cube. So that's how Boolean difference affects this pair. All right, let me save actually Boolean two objects for last. Let's do Boolean split next. So Boolean split in the command bar, and it says select surfaces or polysurfaces to split. I'll just choose one of these for now, enter, and it says select cutting surfaces or polysurfaces, so that'll be the other cube. Okay, now it all looks kind of the same, but let's see if I move one of these out of the way. I see a new line in here, so okay. There's a whole bunch of parts now. So Boolean split gave us a couple different parts to work with. Let me undo all of this, and let's try Boolean split And I'm going to choose, it lets me delete input. I had that set to no before. Let's see what happens if I have yes for delete input. So, oh, all right. So I'm going to select one cube, enter. Now the other cube, enter again. And now if I scoot these out of the way, I no longer have that additional poly surface in the way. Okay, so this lets you kind of salvage the intersection of the two objects that are in your Boolean relationship. All right, let's move on to Boolean intersection. So I'll just choose one cube for now, enter, and then choose the other cube, enter again. And it gets rid of both cubes and only leaves me with the intersection. Now, I did one cube at a time for that. Let me make sure that I've got two separate cubes again. Let me try Boolean intersection. And what if I start with both cubes and then press enter? Same result. So I guess it's up to you how you want to do that one, but you should get the same result either way. Now, lastly, Boolean two objects. I've saved this one for last because if I type Boolean two objects in the command bar and select both of these objects, I don't have to press enter just yet. I've selected them both. And if I just keep clicking, this will cycle through a variety of options for this Boolean relationship. So this is kind of like Boolean union, Boolean difference, Boolean split, and Boolean intersection all at the same time. You can just zip through a variety of possible outcomes and then press enter when you land on the one that you want. So you can probably get away, if you want to, with just using Boolean two objects for all of your closed poly surface relationships. There may be some occasions where it doesn't really behave the way that you want it to, in which case it's perfectly fine to use one of these more specific Boolean commands. Okay, let's move on to, so remember, these are closed poly surfaces. Let's start thinking about meshes for a second. These two, you can see just by all of the polygon faces here that this is a mesh. Generally, you won't see so many individual faces or polygons on a simple closed poly surface. But you'll definitely see those on meshes. So if I select this object here, the command history tells me one closed mesh added to selection. If I click on the other one, oh, I've got two things here. I've got a mesh and a poly surface. So you can see clear as day the difference between a mesh and a poly surface. I don't need the poly surface right now. I'm just going to get rid of that. So if we want to do the same thing as our Boolean commands for poly surfaces, but we want to use meshes instead, let me overlap these two forms so that one is just, oh, we've got another poly surface here. Let me get rid of that. And if I use my viewport camera to inspect this, they're overlapping, but not in a really complex way. This is perfectly reasonable. So the difference here is I have to specify mesh Boolean union. It can't just be Boolean union because Boolean union is looking for poly surfaces to work with. But mesh Boolean union, it knows I'm trying to combine meshes. So, but it works the same way. Select objects to union. This will be one mesh and then the other. Enter. And now, especially when we're in our ghosted mode in our viewport, we can see that the inner portion of this upper mesh is disappeared. And if I just click on one area here, the whole thing highlights. So we have successfully, and plus we can check the command history, one closed mesh added to selection. So let me Command Z or Control Z and undo that. Now we've got two separate meshes again. Let's do mesh Boolean difference. Select objects to subtract from. I'll do the bottom one here. Enter. And then select objects to be subtracted. That'll be this one. Enter. And you'll see our Boolean operations, they function pretty much the same way as they do with closed polysurfaces. It's just we're using meshes instead. So I've Control Z'd, I've got my two meshes back. Let's try mesh Boolean split. I'll start with the bottom one, enter. Now the top one, enter. And let me move these two out of the way now. And now we've got our cross section as its own mesh. Wonderful. All right, so Control Z, undo all of that. And there's one more here, mesh Boolean intersection. We haven't done that one yet. So select first set of objects to intersect. I'll start with the top one in this case, enter. And now the bottom one, enter. And just like with our closed polysurface Booleans, it automatically gets rid of the two parts that we got this cross section from. Unfortunately, I don't think we have mesh Boolean to objects. That would be really cool if we did. Just because I'm hopeful, let me try looking for it. Mesh Boolean to, no. That would be great if we did. But at least we know that the Boolean logic applies the same between polysurfaces and meshes. What if, all right, how do we get meshes? I don't think we've talked about that yet. Let me select these two cubes, copy and paste. I'm going to drag them over this way now, the newly copied cubes. I'm going to select, let me just do one at a time. I'm going to select this cube, and I'm just going to type mesh in the command bar, just mesh. And I get some say in terms of how many polygons are accounted for on this cube. I'm not going to tinker with it right now. I'm just going to hit OK. And we now see something a little different than what we had before. The poly surface that was there initially, it didn't go away. I still have it, but I don't need it anymore, so I'm going to delete that. And I'm going to do the same thing with my other cube here. Mesh in the command bar. Just OK. Select the poly surface that's in the way and get rid of that. And now I can carry on with my mesh Boolean relationships, just like I did with closed polysurfaces. Okay, Boolean. Just in summary here, the Boolean operations are extremely important for most model making processes. So let's do a couple more mesh related commands. So if I just click on this for a second, in the command history, I've got one closed polysurface added to selection. I want to turn it into a mesh, so I'm going to, with it selected, type mesh in the command bar. Just agree to the default number of polygons, that's fine. And I'm going to take my new mesh, or let's see. Okay, this is a poly surface. I don't need this anymore. But the mesh I do want to play with. So let's do a mesh trim. This is the result of a mesh trim. By the way, now that we're working in meshes and slightly more complex forms, it might be fine to switch from ghosted to shaded mode, or even rendered if you prefer. I think, I don't know, if I had some more exciting textures for these, it might be better to work in rendered, but I think for now I'm just going to switch to shaded. So how do we do a mesh trim? I'm going to grab a basic rectangle. I'm going to make a copy of this actually, and stage it nearby. I'm going to use a surface tool, the surface from planar curves, and build a little surface here. But then I'm going to convert this into a mesh, because it has to be, when you're doing mesh operations, it has to be meshes that are working together. So one open mesh added to selection. Excellent. So I'm going to overlap this mesh with the larger form here. Sometimes your viewport camera, by the way, it's like the actual focal point is in a really weird spot. You can sort of resolve this by just selecting some object and kind of taking a lap around. So now it's, the viewport camera is a little more friendly now. All right, so I'm gonna just angle this at some kind of interesting way. That's okay. And let's do mesh trim. So if you remember from our 2D tools and commands, trimming is a matter of choosing a trimming object and then choosing an object to be trimmed. So the plane is really going to be our trimming object. So select cutting object, that'll be the plane, press enter, and then the object to trim, that'll be our kind of weird sculpture thing here. And because I clicked on this side of the cutting object, now all that remains is the upper part. If I Control Z and bring that back, now mesh trim again. Same thing, I'm going to use the plane as the cutting object, enter, and then trim away the top part. And enter to complete the trim command. Now I've got an open mesh. So if I click on this, one open mesh added to selection. What if I Control Z, bring all this stuff back, and do mesh split? So in the command bar, mesh split, it says select objects to split. So now this is, I'm going to start with the form, press enter, and now select cutting object, that'll be the plane, enter. And rather, the trim just deletes one part, but a split it'll just cut through and you can save both parts. And remember, so I just deleted my cutting object so that I could see all this clearly. You can do this without deleting it entirely. If I select it and then type hide in the command bar, it disappears from my view, but it's still available if I just type show in the command bar, right? So, all right, you've either trimmed or split some kind of mesh, and now you need to rebuild it. So there is a wonderful command fill mesh hole. This is really great. Let's give this a try. So let me, for now, I'm just gonna hide this upper part and type fill mesh hole in the command bar, enter. Select mesh edge on hole boundary. So let's just try clicking one of these edges here. Immediately it knows where the hole is and it covers it up for us. It's so cool. And now I've got one closed mesh added to selection. This can save you a lot of time. In the past, I've done this myself, but I've also watched other students try to do this. If you have an open mesh, you have a hole, it seems reasonable to create a new mesh with a similar profile and then Boolean the two together to cover the hole. That could work, but you could also just use fill mesh hole and that'll be fine too. All right, one more thing before we wrap this up. Let me show, so I bring these other objects back. I'll just delete this cutting edge for now. I'm gonna do fill mesh hole for this upper part here. So that looks great, one closed mesh. And I'm gonna bring these two parts really close together, but not all the way. Kind of like that. And maybe I'll even shift their positions a little bit like that. There is a new feature in Rhino 8 that wasn't available with previous iterations of the platform. Let's type in the command bar shrink wrap and then enter. And we're prompted select objects to shrink wrap. So that'll be the top part and the bottom part. Enter. And target edge length. You can try this once and just leave it alone. Let's see what happens if we don't mess with any of these options here. So let me deselect this. Okay, something seems to have changed, but it's not really clear what. So let me Control Z and undo that. Let's try shrink wrap again. Select our two parts, enter, and I'm going to delete input objects, and then target edge length. This is only 0.232. Let me make this a little more dramatic and just say 1. And then OK. All right, now this really changed here. Maybe a little too much. The nuances of that other form have vanished. Let me Control Z, bring these back. One more time, shrink wrap. Let me try moving our, well, hold on. Let me move this other part upwards just a little bit. Shrink wrap. Grab our two parts. And instead of 1, how about like 0.6? And I'm still going to delete inputs. So some of the nuanced geometry of our previous pair of forms is still there, but it's obviously been wrapped up and rounded a little bit. Maybe let me try dropping that figure down from 0.6 to 0.4. So shrink wrap, two objects, and let's see what if 0.4 is any better. Okay, so this is interesting. The target distance really does count. Okay. Yet again, a very, oh, I didn't delete inputs this time. So shrink wrap, you've got a couple of objects really nearby, and you can combine them into one continuous form with shrink wrap. So give that a try. Maybe that's something interesting. By the way, if you're wondering what this weird form was, this was, if we go back to our surface tools, I used our network surface and I created an upright mirrored version of it, and then created surfaces between the two and closed it into one closed poly surface, and then converted that to a mesh. So just in case you were curious. All right, let's put it down there for now. Last thing, and I'm not going to walk us through this one. In this space, use a combination of the 3D tools and commands to create a unique mesh object. Try to build it from scratch, build it using 2D geometry, build some interesting surfaces. You could do it in the round, it could be completely asymmetrical, and use these relationship tools and these mesh tools like we've been using. All right? Thank you all very much. Have fun. I know it's a busy, kind of crowded interface, but it does not take long to get used to, I promise. And it's really, really handy for 3D modeling, 3D printing. You can use this to make assets for video games if you want to. All right, enjoy. Thank you very much.